In this lecture, we are going to study about the demultiplexer and the construction of a 1 to 2 Demux. You can download the notes from the link given in the description. Demultiplexer in short is called as Demux. It is a combinational circuit having one input and many outputs. Depending on the select line's value, the single input is steered to any one of the multiple outputs. That is, the value on the input side appears on any one of the output lines depending on the value of select line. We can see here that Demux is having reverse operation of multiplexer, which had multiple inputs and one output. As the demultiplexer receives one input and distributes among several outputs, it is also called as data distributor. This is a general block diagram of an m by n multiplexer which has m select lines and n output lines, one input. You can see here that we also have enable input which decides circuit to be operational or not. If enable equal to 0, circuit is not operational and all the outputs are zeros. And if enable is high, that is 1, the data from input is transferred to any one of the output depending on the selection line value. For example, when enable is 1 and select inputs are 0, 0, 1, that is the value is 1, the input is transferred to y1. And suppose if we want output at y5, select inputs must be made 101 because the value of 101 is 5. Now let us design a 1 to 2 demultiplexer. We know that for an m by n demultiplexer, there are n output lines and m selection lines, and of course n is equal to 2 power m. So for a 1 to 2 demultiplexer, we must have one selection line and two input lines. This is the block diagram of a 1 to 2 demultiplexer which has one input line labeled as I and two output lines y0, y1, one select line and also enable input. Let us write the truth table. You have enable, select as inputs and y0, y1 as outputs. As we have just discussed, if enable is 0, regardless of the value of s, all the outputs are zeros, and when enable is 1 and s is 0, the input appears at port y0, and when enable is 1 and s is 1, input appears at port y1. Once you have truth table, you can write the equation. Generally we will take the help of K-map, but here K-map is not required. We can directly write from the table. When output is low, we will get 0 only. So we will consider high cases always. We will not consider any low cases. So let us see how do we write for y0. y0 is equal to, when it is high, we will consider y0 is equal to e into s complement because it is 0 and I. When you take y1, when you take y1, it is e into s into I. These are the equations. Once you have the equations, it is easy to design the circuit. You have E, I and S, of course the complemented input also because you have S complement here. This is AND gate. You can see here that you need to take a 3 input AND gate. E, I, S complement is for y0 and E, I and S for y1. This is a 1 to 2 demultiplexer. We can also construct 1 to 4 Demux and 1 to 8 Demux in the same way, which we will be seeing in the next videos.